Hello and good evening, everyone. Good evening, everyone, and welcome to my live stream here in YouTube Live. How's everyone doing? I hope everyone's doing fine. Wow, Colonel Batumbakal, thank you so much for being here so early. Thank you. Uh-oh, please. Stop it. Okay. Huwag naman po kayong magloloko, please. Tama na po. Alright. I hope everything is fine from your end. Anong nangyari sa buhok ko? Ay, nako. Ito yung problema pag you have a curly hair and you don't know how to take care of it. Okay, so here is our dilemma right now. Good evening, Amber. Glitching screen. Okay now. Alright. Okay, so we will have our last live stream in YouTube for this year. I am not yet so sure whether we will have a live stream next week and the week to come. We might be resuming our live stream here in YouTube on the January of 2022. Wow, I couldn't actually believe that we are already entering 2022 soon. So yes, I hope everyone's doing fine. Please do let me know if you still have classes next week, and for the reason is if you don't have classes and you're on a break, we will not have any of our live stream. And I will be live in Facebook still, but in YouTube we will not be having live streaming in YouTube for the reason that I will also give our students break for the next 2 weeks. Still have classes next week. I mean next week. Ambery, next week. If you don't have classes next week, then we will not have our live stream here in YouTube. However, we will still have live stream in Facebook Live, but not in YouTube Live. Okay, so we will be starting in a while. Yes, last week naman ma'am for class. Oh, that's good. Okay, that's great to hear that it is your last week of class and you will have a break. So we will also have a break with our live streaming here in YouTube for the next 2 weeks. Okay, that next 2 weeks will be on the 21st and the 28th of the month. So 2 Tuesdays we will not have live stream here in YouTube. Excuse me, for the reason of our Christmas break. Yay! I'll give you a break and then we will resume our live stream in January. So don't worry. But if you do need, please do leave a comment or say something if you really need an online tutorial for next week. And if not, then we will carry on with our Christmas break next week onwards. Okay. So I guess everyone is okay. So we will start with our topic in maths. Our topic in maths for today, let me just lower down the volume of the music. All right. So our topic in maths for today is on right-angled triangle. Okay, let's see. All right, so we have our right-angled triangle. So when we talked about right-angled triangle, that means that your triangle has the following parts. So when we say right-angled triangle, we will have a right angle, of course, from its name. Let me just turn on. So from its name, we have our 90 degrees here. And since this is 90 degrees, and we all know that a triangle has a total sum of the angles at 180. So that means that these two angles here should have a sum of 90 as well, because we already have a 90 degree. So 90 plus 2 of your 90 will have a total of 180. All right, so that will be your right angled triangle. So in a right angled triangle, you will have one angle that is 90 degrees and the rest will be an acute angle. Now in terms of right angle, we always use the 6 trigonometric functions of a right angle triangle to solve for either the sides or the angles missing. Apart from our Pythagoras theorem, which is c square equals a square plus, hi Maha Blanca, c square equals a square plus b square. Apart from this Pythagoras theorems, we also have our 6 trigonometric functions for right angle triangles. Okay, now but before that, first we have to identify the different parts of our right angle triangle. Here, the side facing our 90 degrees or our right angle triangle is what we call our hypotenuse. Okay, it's called hypotenuse. Then we have 2 acute angles here. Now if we have determined one of the acute angles, the side adjacent to our right angle, we call them legs or sides, it will be yes, but it depends on the sum of these 2 angles. Maha Blanca should be a total of 90. So A plus B should be 90 degrees. You cannot say 180 minus 90 is angle 2. You can say that 180 minus 90 is the sum of the 2 acute angles. So if this is your A and this is your B, A plus B should be 90 degrees. Okay, so your A and your B together is 90 degrees. So A plus B is 90 degrees. The side facing, so this is your A side and this is your B side. The side opposite to your angle is always the small letter of its angle letter. Okay, so the side opposite to your right angle is what we call the hypotenuse, and the 2 other sides are what we call just the sides or just the legs. So based on the angle of reference, so for this case, our angle of reference is in angle A. Okay, this is our angle of reference. So when we say angle of reference, that is where you place your trigonometric function basing from. That's where you base your trigonometric function. So for this case, since this is our angle of reference, the side opposite to it is what we call the opposite side, and the side beside it is what we call the adjacent side. So the side just beside it is what we call adjacent, and the side opposite to it is opposite. However, hypotenuse never change. Okay, so when we say it never changed, for the reason, let's say the angle of reference is on B. So the two sides will change. Okay, so if the reference is in angle B, then this becomes our opposite based on angle B, and this becomes our adjacent based on angle B. Okay, so only the legs or the sides will change. However, the hypotenuse will never change. It's always the side opposite to your right angle triangle. All right, so moving on, I will only introduce first the three trigonometric functions. We have your sine, cosine, sine, cosine, and tangent. Now, there are other three, but the other three are just the reciprocal. So it's easy to remember. Okay, so here we have our sine angle. Okay, based on this is our reference angle. So it will be so opposite over hypotenuse. Ka, which is cosine angle, will be adjacent over hypotenuse. And you have your tangent, which is TOA, that will be opposite over adjacent. All right, so we have your SO, KA, TOA. Now, what are the reciprocal of these trigonometric functions? The reciprocal of these trigonometric functions is just only remember the first letter. So if it is a sine, the opposite or the reciprocal of this will be cosecant. Okay, cosecant is the opposite. So C, it will be the sine, S will be the C, and then that will be just hype over opposite. Okay, if it's a cosecant, the opposite will be secant. So C, it will be the S. Okay, and of course tangent will be cot tangent. So it's just the opposite, and you just need to flip the ratio. All right. Okay, so to find the missing angle or finding the missing side, the very important thing is you need to have at least two known sides or two known parts, an angle or a side, or at least two knowns. Okay, that is what you need, because the ratio has three parts of the formula. So at least you have two known sides. So we can then choose, after we have identified what are the known sides, we can then choose what we need to appropriately use for our ratio to find the unknowns. Okay? So for example, let's try this out. Let's say you are asked to find angle C. Okay, you're asked to find angle C. So since you're asked to find the angle C, then you identify the different givens. So the different givens is you have 14, which is opposite to your right angle. So for sure this is our hypotenuse. And your 6 centimeters is right beside your angle C. That means that this is your adjacent side, because your angle of reference is angle C. Now you go back to SO, KA, TOA. So SO, KA, TOA. For all of this, you have to find which trigonometric function has a hypotenuse and an adjacent. Between the three trigonometric function, it's cosine that has adjacent and hypotenuse. So therefore, you use cosine C, okay, equals adjacent, which is 6, divided by 14 centimeter. Okay, all right. Follow? I hope it's clear. And then you have to know or to solve for the angle. So since C is here, you have to transfer cos to the other side. So that will be a C equals cos inverse of 6 over 14. Can you solve it for me? What is the cos inverse of 6 over 14? Please try to solve it. And type the answer on the chat box. What is the cos inverse of 6 divided by 14? So if there are different types of calculators, scientific calculators, it's either you solve first what is 6 divided by 14, and then you press cos inverse of that answer. There are other calculators as well that would allow you straight away just type in cos inverse and then you put brackets 6 over 14. Okay, so it depends on the calculator that you have, that you are using. Okay, let's see. So this should be around 60 or 50. Okay. I think everyone is still sleeping. Okay. So cos inverse of 6 over 14 will be 64.6 degrees. So that is the value of angle C. So this angle here is 64.6. Now you would know that you are correct because both of these angles should be less than 90. Okay, it's called acute angles. So it should be less than 90 degrees. My scientific calculator is gone. Okay, no problem. All right, so let's try another one. So let's say, for example, we have this and you are asked to find angle X. So first step is identify what is given. The given is based on your unknown angle, 3 is adjacent and 8 is opposite. So with your SOHCAHTOA, all right, with your SOHCAHTOA, it is TOA that has the opposite and adjacent. So therefore, you need to use tangent, okay? Because this is the only one where the givens are present. Adjacent and opposite is in tangent. So then you type tangent x equals opposite, which is 8, divided by adjacent, which is 3. Okay? And then you have x equals tan inverse of 8 over 3. Then you solve. You solve for what is tan inverse of 8 over 3. So tangent inverse of 8 over 3 will give you an x which is 69.4 degrees. All right. Okay, let's move on. I hope it's clear to everyone how to use the 3 different all right, okay. Please do type if you have questions, okay? So we have this. First step is identify what are the givens. The givens are the angle 30, that's the given, and base with your angle 30. 7 is your hypotenuse, and K is your adjacent, right? Based on the given. So since you have adjacent and hypotenuse, so we use K, right? Adjacent and hypotenuse. So you have cosine 30 equals K, meaning adjacent is K over hypotenuse, which is 7. So since you're looking for K, you have to, can you do it again, Mom, please? I quite did not understand. Okay, sure. All right, okay. So again, if you wanted to solve for the unknown, the first thing that you have to determine is for you to know what are the given. So based on this, the given is your angle 30. And then you look into the different given. So here you have 7, which is right opposite to your right angle. So therefore, this is your hypotenuse. And K is beside 30. So since it's beside 30, that means that this is adjacent. Okay? So you have your adjacent and hypotenuse. So based on SOHCAHTOA, the one with adjacent and hypotenuse is cosine, the K. So then you use that to solve for the unknown. So cosine, angle, which is 30 degrees, K, adjacent is K, which is the unknown, over hypotenuse, which is 7. And then all you have to do is cross it, because you need K, right? So you leave K on that side. So that will be K, that will be cosine 30 times 7. All right? And then you solve what is cosine 30 times 7. That will be your K value. So cosine 30, okay, cosine 30 in your calculator times 7. Cosine 30 is somewhere 0.8, right? So times 7, you will have 6.1 centimeter. So K's value is 6.1 centimeter. Now the other way to check whether your answer is correct is you look at your hypotenuse. Your hypotenuse here is 7. That means that both legs here, both legs measure shouldn't go beyond 7, because hypotenuse is your longest side, because that is the one facing your 90 degrees. Remember that the measure of your side has a ratio, or it's proportional to the measure of your angle. So the smaller your angle is, the smaller will be the opposite side. So if your angle is this, then this will be smaller compared to an angle which is bigger than that. Okay? So the smaller the angle, the smaller is the side measure. The bigger the angle, the bigger the side measure. So since it's 90, that means that both of your legs shouldn't go beyond 7 centimeters, because those are small sides. So you would know that you are correct. You will know if you are correct based on your hypotenuse. So that means K is 6.1 centimeter. That is correct. All right. Last one. I think this is the last one. Yes, before we go to science. So this is the last one. Again, first step is you identify what are the givens based on the angle given or angle unknown. So the angle given here is 50. Okay? Then you look at R, which is your unknown, that is opposite. That's opposite. And 4 from your angle is your adjacent, right? Beside it is always adjacent. So going back, SOHCAHTOA, which one has opposite and adjacent? which of the trigonometric function has an opposite and adjacent. So based on the three trigonometric function, it's tangent that has opposite and adjacent. Therefore, you use tangent. So tangent angle is opposite over adjacent. Then you have to replace tangent 50 degrees equals opposite, which is R, over adjacent, which is 4. Alright? And then you cross. Alright? You cross it. So cross this. Cross that. You will get tangent 50 times 4. That will be our R. When we say cross, it's cross multiplication based on the ratio. Okay? Cross multiply. So if you have a division, when you transfer it, it becomes multiplication. It's always the opposite. Okay? So tangent 50 times 4, you solve it. Tangent 50 times 4. Can you type in your answer, please? If you have calculated. Okay. Multiply. Multiply it. Because it's division with R. So since it's R divided by 4, you have to transfer 4, right? So since it's being divided to your R, when you transfer, it becomes multiplication. Remember that when you transfer to the other side of the equation, it's always the opposite operation. So since 4 is under R, meaning it's been divided, so... Wow, that's so big! Tangent 50 times 4. Not 50 times 4. Tangent 50 times 4. Tangent 50 times 4. Not 50 times 4. You press with your calculator, tangent 50, whatever is the answer, times 4. You put brackets, please. Come on, Maha Blanca, you can do it. Tangent 50, the answer, times 4. If you are, yeah, you can enjoy the music here. But I don't. Okay. Not a problem. Before this, so tangent 50 times 4. Okay, no problem, Maha Blanca. Tangent 50 times 4 is 4.8 centimeter. So this is your R. Okay? Alright. So you would know, okay, you would know that your answer is correct. Again, based on the given. So since this is 50 degrees, so opposite to that will be around 40 degrees, right? So for sure it will be greater than 4 centimeters. So it's more of, how would you check it? You can check it based on the given. You compare it based on the given. All right. Yes, so that is the end part of maths. So again, just to recap, if you have any questions, please do type them. Just to recap, that if you have a right angle triangle, amongst all your, as we all know that a triangle has a total sum of the angles at 180 degrees. So since this is 90 degrees, both of this angle A and angle B will be an acute angle which has a sum of 90 as well. Okay, now since they are your acute angles, that means that the sides or the legs will be smaller than the side opposite to your 90 degrees. So opposite to your 90 degrees is what we call the hypotenuse. So since that is the longest side, that means that both of these legs will not be more than your hypotenuse. Okay, so this will be your A and this will be your B. Now when we solve the missing parts, missing side or missing angle, we use the three trigonometric functions with the abbreviation for you to be able to find the ratio with the sides, so ka toa, which means that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Okay, so that is your ratio. And please do take note that as your angle measure, it is in proportion to your side measure. The smaller the angle, the smaller the side measure is. So you would be able to check your answer whether it's correct or not based on the angle measure or based on the side measure. So if the hypotenuse is already 8, measured at 8, therefore your A and B should not go beyond 8 because they have a smaller angle measure. Now if this is a 40 degrees and this is a 5, that means that 40 to make it 90, you need it as 50 degrees. So you would expect the angle of the 50 whose side is opposite should be greater in measure. So it has its ratio or proportion with the measures of your angle. Okay. And then the remaining three trigonometric functions are the reciprocal of your SOHCAHTOA or your sine, cosine, and tangent. And this other trigonometric function will be, for sine, it will be cosecant. For cosine, it will be secant. And for your tangent, it will be cotangent. Okay, I hope that was clear before we proceed to science. Unless there are other questions. No worry for now. All right. So if there are no questions, then we will proceed to science. And our topic for tonight or for today is naming compounds. Now we have already, I think, yeah, I have covered this in one of my science videos that has been released, naming ionic and covalent compounds. However, in that video, I only introduced how to cross. I haven't introduced how to name. Okay, so those are the things that I will be including on my next video for science, naming compounds. So I will be releasing the next science video, I think next week or next week, which is on naming compounds. All right, so when we say naming compounds, So a compound, by the way, is a substance which is composed of two or more elements. Okay, it is a composition of two or more elements which is combined in a specific ratio. And I have shown that in one of my videos, how are the ratios are being considered based on their charges. Okay, remember, if you have Na plus and Cl minus, when you create your compound, it will be crossing your signs or crossing the charge number, and you will get an NaCl. So first thing is you have to know the specific ratios that would be present in your compound. The second thing that you have to understand, apart from the ratio, is what kind of bond, bond is holding the compound together. So we have two types of bond. We have what we call the ionic bonding, and we have what we call the covalent bonding. So when we say ionic bonding is between, let me just write it here. Ionic bonding is between a metal and a non-metal. Okay, so first is you have to be familiar what are the bonds, so that you would be able to name your compound accordingly. So if it is ionic bonding, it is between a metal and a non-metal. All right, so that is for your ionic bonding. So when we name ionic bonding, we only name them, so the metal part's name will not change, okay, but the non-metal part's name will change by replacing the end part to an IDE. I think we have covered that previously, right? So if you have NaCl, then this will be sodium chloride, right? You have your IDE on the last. So it will not change in terms of your metal part. It would still be the same, it's sodium, but the non-metal part's name will have to change the ending of the element's name to IDE. But we have several metals in the transition. The transition metals are the metals in the middle of your periodic table. So if this is your periodic table, those that are in the middle are mostly where your transition metals are found. When we say transition metals, these are metals with two or more charges. So more than one possible charge. So then they have a different type of naming. So how does the naming of these transition metals? We have two ways to name them, okay? It's either we use their Latin name or their Greek name. So for example, iron, Fe, you can use ferrous or ferric, okay? Because iron can have +2 or +3. I think it's here if I'm not wrong. Yeah, here. All right. Oh, okay. How will you know if it's ionic or covalent? Ionic is between metal and a non-metal. Covalent is between non-metals. Okay? Covalent is between non-metals. Ionic is because they are transferring electrons, they are metals and non-metals. So ionic compounds are being formed by transferring electrons. All right. I hope I answered your question, Ambery. Okay, so that is the difference. So here, these are some of the these are some of the elements with different charges, or two charges or more. So iron, you have Fe plus 2 or Fe3 plus. Okay, so if it's 2 plus, then you name it as iron brackets 2. Okay, Roman numeral 2. If it's 3, it's iron bracket Roman numeral 3. So that is how you name them. All right. So if it's copper, copper can have plus 1, or copper can have 2 plus. So it will be copper, if it's a plus 1, bracket Roman numeral 1. And if it's 2 plus, then it will be copper and then Roman numeral 2. All right. So that is how you use or name if it's a transition metal. So how do we name them? Okay, this is how the ionic compounds will be named based on this flow. Okay, so first is you have to, if the compound contains a metal and a non-metal, then it is an ionic. Okay, it's an ionic compound. So first is your metal a cation, which has only one charge? So if it is a yes, then you just name the metal as it is, okay, when you name it, and then you add IDE on the non-metal nomenclature or non-metal's name. If your ionic or the metal cation has 2 or more possible, then you name it based on the specific charge, and then you put an IDE on the non-metal side. So example, let's have an example. Oh, okay, it's not here. Okay, so let's say for example we have Al2O3, and then we have FeCl2. So if we have this, the first thing that you have to identify, is this a metal that is in the transition group? If not, aluminum is not in the transition group. Therefore, you just name this as aluminum. Okay, and then that's oxygen, so it becomes oxide. All right, now Fe. Fe is one of the transition metals. It is in the middle of your periodic table. So since it's one of the transition metals, the first step that you have to do is to identify what is the charge of Fe here. The charge of Fe here, since Al, yes, that's correct, Ambri. So since Cl minus, we know that Cl is -1, so you just need to cross back the charges. That means that Fe here was +2. So since Fe is +2, then you write iron 1 mom. Yes, iron 2, okay, Roman numeral 2, and then that's a Cl, so it's a chloride. Okay, so iron 2 chloride. All right, I hope that was clear. So when we name again, we use the Roman numeral if it is a cation with 2 or more charges. But if it is a cation with just one, with a specific charge, then just the name itself. Okay? Now, how about if we have ionic species being bonded to a polyatomic ions? What is a polyatomic ions? Polyatomic ions are ions which is composed of 2 or more, okay, 2 or more ions that are being charged, okay, like NH4 plus, H3O plus, or CO3 2 minus, ClO3 minus. So these are charged, okay, these are charged 2 or more metals together. So we call them polyatomic ions. Okay, these are consisting of a combination of 2 or more atoms or 2 or more elements. What is poop made of, Mom? It's poop of the cat has a compound called butyric acid. Butyric acid. Butyric acid. I think it's an I acid. Yeah. Butyric acid is one of your butyric, yeah. One of your acid. This is actually one of your organic substances. Why are you so curious with your poop? Why are you so curious with your poop? Okay. Yeah. So it's mostly what is poly what? Polyatomic, not polytonic. Polyatomic ions, not polytonic. Polyatomic ions are ions that are composed of two or more atoms. Yep. Are we good? Can we continue? Okay. So you have your polyatomic ions, which are consist of combination of two or more atoms. Yes. So formulas are actually being determined following um, the charging, okay, of your element that compose your polyatomic ions. So you have your CO3 2 minus, and most of these not most, all of these polyatomic ions are actually a covalent bonding. Okay, it's a covalent bonding. Why are they a covalent bonding? It's because they are composed of most of them, okay? Most of them are covalent bonding because they are composed of nonmetals. So the formula when we use a polyatomic ion combined with a metal or a monoatomic ion, then we just need to use the name of the neutral formula of your metal followed by the name of the polyatomic ion as well. Okay, so for example, we have this. All right, we have this as your formula. So first is the strategy here is you have to identify what are the cations and the anions in each compound. What is the positively charged and the negatively charged of that compound? So first, that is your first, okay? And then you combine the names for each by just how it is neutrally named by removing the word ion. So you have an Fe here, okay? Fe, and then if it is a transition metal, what do? We cross back the charge. So since this is a 3, that means that iron had a positive 3. So when you name this will be iron bracket 3 because iron has 3. All right, so that's Fe2 bracket SO4 3. So you just need to cross. So that means that Fe had a plus 3 and SO4 had a minus 2. Okay, so with that, you will be able to name this as iron bracket 3, okay, because that is the charge of iron. And then SO4 is sulfate. So you will have sulfate. So it's iron 3 sulfate. Or that is what you call ferric sulfate, but it's easier to use this SI unit, the standard nomenclature, standard naming. Right. Next one, you have your Al and then OH. So Al, if you cross back this, Al had a charge of +3. However, Al is not a transition metal. Therefore, we just name it as aluminum. And then OH is hydroxide ion. So just place hydroxide without the word ion. Okay. And then the last one, you have Hg and O2. So Hg2O, again, you just need to cross back the charging. So that means that Hg has +1 and O2 is 2 negative. So since Hg is one of your transition metal, which is your mercury, so you write mercury bracket 1 because that's the charge of mercury +1, and then oxide. Okay? Be careful not to be confused with the subscript in the formula with the charge. So what you need to do is, for example, the subscript of Fe2, it does not mean that the charge of Fe is 2. It's just a subscript. So you have to cross it. Cross multiply. Okay? All right, so the last part will be the covalent compound. What is a subscript? A subscript is a number that would tell you the number of atoms. The subscript is the number that would tell you the number of atoms. So if you have a subscript that is a 2, so let's say for this one, so if you have like H2O, all right, so that means that in this compound there is 1 oxygen with 2 hydrogen. Okay, that is because it's based on the charge. So for example, oxygen is 2 minus, and then hydrogen is +1. So for an O, which is a 2 minus, for it to be stable, it needs to have no charge, right? For it to be stable, the compound or any of your elements should have an 8 electrons on its outermost. That's what we call your octet rule. So since oxygen needs, it has 2 electrons, that means that it has to have 2 other positive charge. So one of this hydrogen will charge with one of the 2, and then another hydrogen will also charge with the other of the 2. So that is the reason why it's H2O. So in terms of writing, you just need to cross the number. So that's H2O. Okay. So if you have, let's say, Al, the 3 plus, you need 3 electrons. So you have Al, you have 3, right? You need 3. So one of it, 2 of it will be with oxygen. Okay? So if that is the case, there's one more that is extra. So another oxygen will pair with this, and since that is an oxygen which is 2 negative, so you will have a 1 negative extra. So you need another Al, and once one of the charge of Al will bond with oxygen, you will have 2 positive extras, so another O. So that's the reason why, if you would see, you need 2 Al and 3 oxygen. So if you have Al3O2, so when you write this as a compound, it will be Al2O3. That means that this compound or these ions, when they come together to bond, you need 2 aluminum and 3 oxygen to balance the charges. Oh, like H plus, yes. So H positive and O2 negative. So when you cross, you need 2 hydrogens and 1 oxygen to balance the charges, okay, to neutralize the charge. For an element or an ion to be stable, it has to have a 0 charge. Okay. All right. So the last one that we will discuss tonight is covalent compounds. When we say covalent compounds, covalent means sharing. Okay? They are sharing electrons. So covalent compounds has different, in terms of naming, they have a different way of naming because since they are sharing, so since your elements are sharing your compounds, we have to use your prefixes. Okay. Prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So these prefixes are being used for your first element and for your second element. Okay, so prefixes, the name of your first element will be the same as how it appears in the formula, but the second element's name, you have to change it to IDE. All right, so it's an IDE. However, there is a catch. The catch is, if the first element is only one, you have to omit the word mono. You don't need to write mono. For example, CO. You don't write monocarbon monoxide. No. You have to omit mono for the first element. So you name this as carbon. And since you only have 1 oxygen, then you say monoxide. You drop as well the letter A. If the element's name is with how should I say it, is with an O or a vowel, you have to drop it. You have to drop your A of your prefixes. So hexa, penta, octa, instead of saying hexaoxide, it will be hexoxide. Tetraoxide, it will be tetroxide. So you drop A. Okay, the last letter of your prefix is A, then you have to drop it. Okay, so again, if the first element is only 1, you don't need to write mono. If the second element is only 1, then that's the time you write mono. All right, let's try. So if you have NF3, okay, NF3, you have 1 nitrogen, so you just name it as nitrogen. So this will be nitrogen. Okay, you don't need to change the name of the first element, nitrogen. And since you have 3 of your oxygen here, it's NF3, right? So you have 3 of your, oxygen, 3 of your fluorine, so it will be nitrogen, tri, that's the prefix of 3, trifluoride. Okay, instead of writing fluorine, you write fluoride. It's the IDE. Okay, the next one is you have N2, can you see it? N2O4. So N2O4, N2O4. So since you have 2 of your nitrogen, so you use the prefix di for 2. Di, you don't change the name, dinitrogen. And then you have 4 of your oxygen. So supposedly it's tetra But since it's an oxygen, it's O, so you drop the A and then you place tetroxide. Okay. All right. And then if you are, so you have to think about it. Okay, make sure that the prefixes matches the subscript, and if the molecular formula is an oxide or a vowel O, then it has to drop the A and change it to just the oxide, tetroxide. All right, so if you are asked to write a chemical formula like this one, sulfur tetrafluoride, so it's easy. You know that it's a sulfur, that means it's just one. Okay, sulfur, and then tetra means 4, so S4. All right, the other one is you have tetraphosphorus, so tetra means 4, so P4, that's tetraphosphorus, and it says decasulfide. Deca means 10, so S is sulfide, sulfur is sulfide, so P4S10, not PS4. PS4 is a gaming thing. Okay, P4S10. Question with a naming. Before we, I think we can play one game with T. What is wrong with me? Louisa Small. Who is Louisa Small? Voided FYI. What's the octet rule? The octet rule states that for an element to be stable, it needs to have 8 electrons on its outermost, or it has to have a complete number of electrons. So in your electron configuration, the first orbit is 2. Okay, the second orbit, you have an S2 and a P6, so 6 plus 2 is 8. The third orbit, you also have an S2 and a P6, so it's always an 8. So for your element to be stable, it has to have 8 electrons, because each shell, so each, why is non-metal and now just needs to share, not transfer? Why is, okay, wow, that is a good question. Why is metal and non-metal needs to share? To transfer and not share. Wow. Okay. Why do you think? Why do you think? Okay. Well, that's a good question. Okay. The reason being why non-metals tends to transfer and not share is because of the number of electrons in their outermost shell. Okay? It's the number of electrons in the outermost shell. So let's go back to your electron configuration. So if you remember, if you have Na, all right, for Na, the outermost electron, which is it has the S, it has a 1. So in your second electron orbital, let's say, third electron orbital, so you have S2, P6 on your second level orbit, your N is 2. And then on the third one, you only have S1 being filled up, and P is empty. It doesn't have an electron. So Na, it's easier, okay? Lesser amount of energy required to lose this, remove this. So since it's easier to just remove it, then Na becomes positive, okay? Because it has only one electron in its outermost orbital. However, for a non-metal, all right, for a non-metal, let's say chlorine. For a non-metal, right, so S2, and then it has P5. For a non-metal, it has more electrons in its outermost shell. So by receiving one more electron, it's easier for a non-metal to just receive rather than remove all this 7, right? So that is the reason why, since all of your, or almost all of your non-metals has more electrons on the outermost, they'd rather share their electrons, because all of them needs electrons. So since they have more electrons on its outermost, they'd rather share it rather than transferring the whole 7 or receiving 1. Okay, it's either I will receive 7 of yours or I will receive only 1. So it's easier to share the 7 and then the other one to make both 8, because both of them needs 8 electrons. So they'd rather share that 1 electron, okay, compared to a non-metal wherein it has only 1. I hope I answered your question. Oh, thank you, Kerna. No, it's not about being similar. It's okay. All right. Thanks, Colonel, for being here. Yes, so rather than removing 7 and receiving 7, it's better to just share what is missing, which is 1. Because it has a lot of, it's either you remove the whole thing or receive. So it's easier for your metals to just remove the electrons because it's only a few, like 1 or 2 of it. So just remove it. So by transferring it, then it is being transferred. That means it's an ionic bond. But for covalent, which is both nonmetals having a lot of electrons in the outermost shell, you just rather share that 1 electron that you need rather than removing the 7. Okay, so I think we will not have time to do the t-shirt game because it's already 8. Unless there are other questions for maths and science before we end our live stream tonight. Yes, we will play next time. I hope I answered your question, Emery. Yeah. It's on the number of electrons on your outermost. Non-metals has more electrons in its outermost, so it's better to share rather than remove them. Just share because I only need 1 more, so just share. Otherwise, for metals, they will only have 1 or 2 electrons on the outermost, so it's easier for it to remove. Okay, so I hope that you have learned something tonight, and I hope that I was able to explain covalent and ionic bond and naming them, and then at the same time, wait, it's getting okay. And at the same time, I hope that I was able as well to explain to you right angle triangles better as well, for you to understand your SOHCAHTOA and as well as your naming of ionic and covalent bonds. Okay, we'll wait for a while. If there are no questions, then I will be seeing you. Oh, yeah. I was just asking whether you need one more tutorial next week or not, since you will be on holiday break. Yay! Everyone is on holiday break. Holiday break next week. So you are on Christmas break. So we might not have, I will post in the community if we will have an online tutorial with Teacher Maria or not. Otherwise, I'll just be live and we will be playing the TKO and other games, brain teaser games. Okay, so I hope that you are able to understand our topic for tonight, and I hope that I was able to help as well with your topics in school. So if there are no questions and no other topics that you wanted to ask, thank you very much for being here tonight. Thank you for being with me for the whole 1 hour. And as always, as Teacher Maria would say, please do live your life to the fullest, learn something new every day, and love one another as how our God loves us. See you next week. Crossing finger, hopefully. See you next week and have a blessed week ahead. Goodbye, everyone. Bye. See you next week. Thank you for being here tonight. Thank you, Maha Blanca. Thank you, Ambery. Thank you, Colonel Batumbakal. Thank you for being with us tonight. And see you all next week for another maths and science topics to be discussed, or otherwise we will be playing the game of TKO next week. Bye-bye.